In today's video, I'm going to be checking out tone controls with square wave. I could use sine wave, but sine wave basically that only consists of one frequency, and I could do the testing, but I would have to test the unit at a bunch of different frequencies and then do some plotting on a piece of paper, and that's pretty time consuming. So I am going to be using a square wave. Basically, when you hear the word square wave, you have to think, well, you're basically testing the unit with a bunch of different frequencies at the same time. That's one thing people, I don't think, they probably don't really realize that or think about it very much. And the square wave, that's made up of the fundamental frequency. Say, if I was feeding in a 400 hertz square wave, the fundamental is 400 hertz. And the square wave is made up of the fundamental and the odd numbered harmonics. For example, so if I took 400 times 3, that would be 1200 hertz, that would be the third harmonic. And then if I took 400 times 5 is 2000 hertz, that would be the fifth harmonic. And of course 4000 times 7 is 2800, that would be the seventh harmonic. So that's basically how that works. Also, for example, say if we did use that 400 hertz square wave, basically we would be checking the response of the unit here, the receiver, amplifier, whatever you have, from 40 to 4000 hertz. The rule is, that's the way I learned it a long time ago, it's from 1/10 of the fundamental. So if the fundamental is 400 hertz, 1/10 of that would be 40, and that would be up to 10 times the fundamental. So 10 times 400 is, of course, 4000. So if you want to check the audio band from 20 to 20,000 hertz, we need to use two frequencies. Of course, we can't use the square wave to check out the phono circuits because of the equalization. So we'll go ahead and see how I got things hooked up. So the first thing we're going to do here is hook up the scope directly to the generator, to the square wave generator, or rather the square wave part of the function generator, to make sure we're getting a decent square wave. Of course, because if we're not getting a decent square wave, we're really going to be thrown off. So we'll take a look at this quick. So here's the square wave, 1000 hertz, and I like to set it up so I can see about 2 to 3 cycles, which you can see right now. That's exactly what's happening. I'm using an 8 ohm dummy load, and you can see here the wires, loudspeaker wires, coming of course from the loudspeaker terminals, and I've got both hooked. Both channels are hooked up to the dummy load. Again, this is the 8 ohm dummy load. So the cable I'm using, this goes to the, in here goes to the function generator. This little thing here is nothing but a 50 ohm terminating resistor. This is a 50 ohm generator. If we don't do that, your signal is basically going to be twice as high. It's going to be reading double, and we don't want that. And this is actually the end here, and I bought these from, well, where else? eBay, and I'm just going to use them. I can hook them, put it into the aux. So I'll do that next. And we can see that right there. Okay, what about the output now? Well, the way I do it is I turn my function generator really down, really low, and I turn the volume control on the receiver and amplifier, I turn that all the way up. So my next step, before I forget, I just had the unit turn on and shut it off now again. I hook up an AC voltmeter across the dummy load. Basically what I want to have is, this is the way I like to do it, I have 1 watt output into 8 ohms, and then I would read on the meter about 2.82 or 2.83 volts. It doesn't really have to be that exact, but that's giving you a 1 watt output. And what I do for that is I turn the volume control all the way up and the function generator control all the way down, and then I slowly bring up the function generator. and until I reach 2.83 volts. You can't have the function generator turned all the way up and volume turned all the way up. That's not going to end well. So I've got the volume down and the function generator all the way down now. Let's go ahead and turn things up. Excuse me, I have a cold. I don't have a terminal disease or anything. Turn the volume control up. I'm maxed out right now, and we're putting out, I'm only feeding in a few millivolts into the aux input, 447 millivolts. So again, the meter's in the AC position. Let me bring this up. 1.6. So 2.86 volts right there, and I'm feeding in this particular unit about 20 millivolts, I think. And the wave I'm using is a square wave. So I'm going to bring it down a little bit, or rather now up a little bit. Again, it doesn't have to be like ballpark, or rather it can be ballpark, I meant to say, somewhere around there. So that should really like do it. 2.82, 8, and that should be about 1 watt. Now this particular receiver even has a watt meter on it. You can actually read the output. So we'll take a look at that real quick. I don't know if that can be seen right here, but that's right where that pointer is at right there, that orange pointer. That's 1 watt. So you can see I'm really close. And look at the other channel. It's actually pretty close on there, although it doesn't look like that, but that's the angle how we're looking at things. It might not be always 100%, but that's not really a issue. So now I'm going to shut the unit off again, then hook up the oscilloscope probes, because that's what we basically want to do. 1 probe for each channel. Now we can see I got both scope probes hooked up, and the probes itself are I'm using the ×1 position here, which is good enough for audio work. Basically a direct probe, I guess you could say. So another thing which deserves mentioning, if you had listened earlier to what I said, you would see here this 1000 hertz square wave is actually going to cover from 100 hertz to 10,000 hertz. The 1000 divided by 10 gives us 100, and if we take the 1000 times by 10 it gives us 10,000. Because on this, say if this receiver was rated for say 20,000 hertz, now the tone controls are not going to cover that. They might cover from, let's say, from 100 to 10,000 hertz or something. I think a sister model of this unit here, of this SX-590, I think that covers around there, and this should be the same. I don't have specs for this, but I venture to say that's that. So I only need to feed in 1 frequency. Now both of these tone controls are in, even though I have the unit on its side for space reasons. Both of these tone controls are basically in a neutral position. You can see here it's got like this control has an indentation here, and I've got them both exactly in the middle. So we'll take a look at the scope, and that's how things should look there. I've got pretty decent square waves. And what am I feeding in here? I'm feeding in 23 millivolts. That's my signal. Of course, it's going to depend on whatever unit you're testing. Again, this is a square wave. So the first thing I'm going to do is I'm going to basically turn down the bass control. And what's going to happen, or rather what should happen, we're going to have a downward slant toward the back, basically towards the trailing edge. So I don't know how I'm going to do this here. I'll try to hold the camera and turn at the same time. So my hands might be shaking here a little bit, so you should watch the back end of that square wave. That should be going down. And see, it actually is right there. The back is right here, and it's actually trailing down, getting lower toward the back, and so that's actually a correct response. So next we're going to turn the bass control all the way up. Again, I don't know if I mentioned, the treble is in a neutral position now. So we take the bass and then we turn that all the way up. I'll put it back in a neutral position right now. It's kind of hard for me to see what's neutral here. Okay, I'll hold the camera again, and this time we want the trailing edge, which is the back. It's going to be high. Basically, we're going to have an upward slant from left to right. So here we go. The bass control is going to be turned up, and we're looking for upward slant from left to right. Hopefully it can be seen. I'm shaking a little bit here. And there it goes. See? The back's going to be higher than the front. That can be, I don't know if that can be seen again. I'll try to come a little bit closer. And there it is. The trailing edge is higher than the front. So much for that test. Everything so good so far. So next we do the treble, and what we're going to do is turn the treble down, and what we're looking for basically is the front is going to be basically low. So we're going to have a downward slant from the back to the front. And I should mention right now that when I'm testing the treble controls, the bass control is going to be in a neutral position. And because earlier when I was testing the bass controls, the treble was in a neutral position, and this time it's the opposite way around. So I'm testing the treble, the bass is in neutral position. So we'll see right now if what I said is correct. Again, I said the downward slant from the back to the front, and there we go. The back is higher than the front. We're actually getting that downward slant. So what we're going to do now is basically turn the treble control all the way up, and what we would get, we would have the basically the leading edge, basically that's going to be pulled up, if that kind of makes sense. So here we go, the front's going to be pulled up, and that's basically what's happening right there. So I'd say we're good to go. Now what happens if I turn down both bass and treble at the same time? We're going to have the leading and the trailing edge turned down. I don't know if this can be seen easily or followed. You can see right now I'm turning on the treble, and the leading edge is going down. And if I turn on the bass, the trailing edge going down. Now if I do both, we're going to get something like that. Both is actually turned down. Kind of hard to follow, but I think it's correct. So what do we got if the bass and the treble's turned up? Basically, we're going to have both the leading and the trailing edge turned up. I don't know if I'm going to try to show this. This is not going to be that easy. Now I'm turning the bass up now. You can see the trailing edge is going up. Again, I'm going to turn up the treble, leading edge is going up. Now I'm going to do both, and you're going to get like a funky looking wave right there, like that. Well, you can kind of see that the action is actually happening though if you manipulate each control at the same time. So what happens if you're feeding in a 1000 hertz square wave into the unit, and you got the tone controls in a neutral position, you got all the filters off, loudness is off, and you're getting not this, but you're getting, say, something like that. That means something is definitely wrong in the unit. I would go ahead and maybe start swapping out capacitors in the tone control units. Electrolytic capacitors, a lot of times that makes all the difference in the world. Basically just a general check of components, could even be a transistor or something. You would have to basically check all that. Nowadays it's a lot easier just to shotgun all the parts and swap them out. That would probably be quickest, especially since it make more sense since the electrolytic capacitors are often quite old. Anything I have to add to this? Well, I can't think of anything right now. So, thanks for watching.